Hey, so what is the difference between THC, THC-A, and CBD? Those are all cannabinoids. What's a cannabinoid? Those are chemical compounds that are found in marijuana. That is probably a hot topic of the day. THC is tetrahydrocannabinol. That is the active ingredient in marijuana, and that's also the psychoactive substance. That's responsible for the high that you get, the euphoria associated with marijuana use, either by ingestion or by smoking. And so it actually does have therapeutic relief. Of course, it's currently classified by the federal government as a class 1 narcotic. That means it has no accepted medical beneficial uses, but that is being challenged, and I think they're currently considering reclassifying marijuana into a Schedule 2 or Schedule 3. It's currently Schedule 1, so it's illegal to possess or use anywhere in the United States. Although that is kind of in question because several states have legalized it both recreationally as well as medicinally, because it does have medicinal benefit, pain relief, appetite stimulation. That kind of gives you the munchies, if you will. I guess Doritos would probably be in favor of legalizing marijuana. It's also useful for nausea and vomiting relief as well too. So it does have some use. If we kind of look at the chemical structure of marijuana, we can actually go to PubChem. We can search for THC right here. And so this is tetrahydrocannabinol. There's a few alternative names: dronabinol, marinol. Most people just call it THC or delta 9 THC. It has a molecular weight of 314.5 grams per mole. And it tells you a little bit about its uses right here. And then, of course, we have the structure as well. So this has mainly a carbon backbone with 3 rings in it. The delta 9 is up here at the top. And so that's, that's where they call it delta 9, because it refers to this double bond up here. And we can again take a look at more chemical structure. What I like to do is download the SMILES code. That's the single molecular input line entry system. That's the single one-dimensional code. And let's look at THC in Mo. So I'm going to open this up. I'm going to copy my SMILES code right here. Get a little smiley face. That seems highly appropriate for marijuana. We're just going to call this THC. And so there is the structure of marijuana, the active ingredient, THC. Right? Now, if I add a force field onto here, I can energy minimize to ensure that I've got a optimized structure. And there is my optimized structure of THC. Right? Let's, if we look at the space filling model right now, we can also kind of see that there's a lot of carbon atoms. All those gray atoms are carbon. There are 2 polar functional groups. There is a hydroxyl here, and there's an ether down at the bottom. There's the ether oxygen right there. And then there's this long carbon chain, so there's 5 carbons. So this is going to be predominantly a hydrophobic compound. If we look at the ligand properties right here, so we can also look at the log P, and the log P is the octanol water partition coefficient. That is 5.72. The higher the log P, the more hydrophobic the compound is. The lower it tends towards the water phase. So if it's less than 1, it's going to be more of a polar compound. Well, 5.72 is very hydrophobic, mainly attributed to all these carbon atoms. That's why it gets so into your brain so easily, because your brain is basically one big fat globule. Essentially, there's a lot of fat in your brain, mainly due to neuroprotectivity. And as such, since there's all that hydrophobicity in the brain, that forms what's called the blood-brain barrier, right? And so extremely high compounds with a high log P get into the brain very easily. And marijuana gets in there, and that's what gets it in as easily as possible. So that's THC. Now, if I take this hydrogen atom, and if I make that a carbon, and then let's make this an oxygen, and it probably would be better for me to optimize this with, I need to see this a little bit better. We'll put another oxygen over here, and we're going to make this a carboxylic acid, right? So there's my carboxylic acid. Now, since I've modified this, I need to re-energy minimize it. And let's go ahead and re-minimize. And there's a new compound. So this is basically THC. This is what we call THC-A. And THC-A you've probably heard about because this substance is actually legal in the United States and elsewhere. Just by adding that carboxylic acid right here, that converts this, that reduces the ability to bind to cannabis receptors in the brain, and this has no psychoactive response. So there's no high or euphoria that you get, so this compound right here does have some benefit, right? So it is useful as a pain reliever, as well as it's got anti-inflammatory and neuroprotective properties, and it also helps to reduce nausea, and it can help in the immune system function as well. And this could be consumed in edibles. I think in the United States it will be consumed as an edible. However, here's the deal. When this compound can combust, and if you heat this compound up above about 93 to 140 degrees Celsius, or about 200 to 290 degrees Fahrenheit, such as if you're smoking or vaping, then this carboxylic acid will basically come off, and essentially because it's carboxylic acid, we have a CO2. So that will release as carbon dioxide. It converts back to THC, and that'll get you high. So if you smoke or vape THC-A, that compound will immediately convert it to THC, and then that will have the same effect as THC, not THC-A. So that's the main difference between THC and THC-A, right? So, and again, let's just kind of look to see what happened to the log P. Notice my log P is still very high with THC-A. It's 5.32, so it went down a little bit because I added this very polar carboxylic acid. However, it's still very hydrophobic. It'll still get in the brain. It just won't bind to the same cannabis receptors the same way, right? So that's THC. Now, let's look at another compound, and I'm going to go here, and let's look at CBD, right? So what is CBD? That's cannabidiol, right? And so this is also another cannabinoid. Here's the molecular formula here. This is the form that's found in the drug Epidiolex, which is actually an FDA-approved medication. And so this compound does have accepted medical benefit. It is legal, and it's legal to be prescribed in all 50 states. It reduces anxiety and depression. It's used for anti-inflammatory and pain relief effects. It's also used to treat epilepsy. That's the main FDA-approved function of Epidiolex. And it may help in insomnia as well as neuroprotection as well too. So it does interact with your cannabis 1 and cannabis 2 receptors, but it will not get you high in the same way. So now, what's the difference in structure? Let's come down here and get the SMILES code right here. And I'm going to bring that in to Mo. Get that away. And we're going to click the little smiley face. CBD. So here's CBD. And now, wow, look at this. This has a different structure right now. First of all, I probably want to just fix the charges and do a minimization. And that's that. And so now what we notice here is this kind of has been broken up apart, right? So up here, this is that delta 9 ring up in this region, and here's the phenolic, the phenol. But now notice that this hydroxyl used to be connected to these carbons over here. Now they're disconnected, so this is completely separate, right? And so that enables this phenolic ring to be separated from our delta 9 ring. And if you look on it, it's no longer even in plane, right? Because now we've got a lot more flexibility in the ring, right? And due to that difference in structure, that's what's mainly making CBD unable to bind in the same way as THC. And so you're not going to be able to get high on CBD. However, it is going to be very useful at treating a lot of conditions, right? So it is going to be a very useful compound. So that's the difference between CBD as well as THC-A as well as THC. So I hope you enjoyed this video, and I hope you found this informative. If you like this, feel free to hit the like button down below. You can also subscribe to the channel if you like more interesting content like this, and as well as feel free to leave a comment if you want to ask a question or you want to add some kind of comment. So thank you, and have a nice day.